In this question, we are looking at a reaction, at a first order reaction where we convert A into a product P. And this time we are asked to calculate how much P have we got left after a certain amount of time. And we've been given a rate constant. So what does this actually mean? Let's just quickly draw a graph. So here is time and here is the concentration. And let's say we are starting here with A, that is our initial concentration of A, and in a first order reaction we would go down like that. So what does that mean for the concentration of P? Well, the concentration of P, we don't have P at the beginning, so we would get something like this. And what we can see is that at any given time, the concentration of P, so that's P, the concentration of P and the concentration of A at that time, so that's our A curve, so they both give together, they give our initial concentration of AI, our initial concentration of A. So we can write the initial concentration of A is always at any time the concentration of A at the time point that we are looking at plus the concentration of the product that we are looking at. And that is exactly what we are trying to find out. So what we can do is we can simply rearrange this equation and say P, our final concentration of P at any given time point, equals the initial concentration of A minus the final concentration of A. That's the concentration of A at that time point. And we have quite a handy equation for this final concentration, because we know that A final for first order reaction equals A initial times E to the power of minus K times T final minus T initial. Now in our case, T initial, this here would be 0. So we have A final equals A initial times E minus K times T final that we want to look at. So all we need to do is we need to calculate A final. What have we got left of A after our 30 seconds? So we can do this very easily by saying A final equals 305 millimolar times E to the power of minus 0.0117 times 37 seconds. I better put that into brackets. So this gives us if we put that in the calculator, 305 millimolar times E to the power of negative 0.433, something like that. That gives us 305 millimolar times, and if we calculate that in the calculator, that gives us 0.649. And we would get for our A final at that point, we get roughly 198 millimolar with rounding. Now that's our A final. Well, we want to know the P final. So for P final, we have our A initial, that was 305 millimolar, minus our A final, which we just calculated, which is 198 millimolar. And if we do this calculation, we get our P final concentration equals 305 minus 198. That gives us 107 millimolar. So at this time point, 37 seconds in, we have 107 millimolar of the product and 198 millimolar of our reactant A. So I hope this makes sense.